This Headless Professor video will show you how to use a sample versus norms design when you're really comparing interval or ratio scaled data. Specifically, let's take a look at a situation where we have data coming from the California Department of Education from the CAASPP achievement test and the statewide norms on that test. Let's scroll down and we see that Table 2 gives us the mean scores in this third column here for different grade levels. If you scroll down to Table 3, you will see another set of mean scores. Table 3 is for mathematics achievement, and Table 2 was for English language arts. Let's suppose that in my example, the students are in the 11th grade, they're high school students, and we're testing them on math. And here would be the mean statewide score, the norm for all students on math achievement, 2560.3. Now, did our students score significantly higher than that? Let's find out. Let's use a t-test. We're going to go to the Vassar Stats site. We're going to click over here, t-tests, and then we're going to select a sample versus norms t-test. They call it a single sample t-test. So we click on that. We're going to type in that hypothetical population mean, 2560.3. That was the mean we got from our tables here for the CAASPP. And then I've given you in your assignment some fictitious test scores for your particular sample, the Roadrunner Academy. You can just copy those and paste them right into the box. In real life, you can take your scores from an Excel or Google sheet and just highlight the entire column and paste them right in here. Now we click on Calculate and notice what we are given. We're told our sample size. You should already know that, and this will be kind of an error checker. If the n shown here is not your sample size, you forgot to enter some of the data. Here is the standard deviation of your sample, the mean of your sample. It repeats the mean of your population, so you can see the difference between the two. In this case, the sample mean was actually lower than our population mean. This is what we call getting data in the unexpected direction because it does not match the hypothesis. But we are still left with the question, is this difference between the two means, the sample mean and the population mean, is that a statistically significant difference? You are going to report three things in your project and abstract. You're going to report the t-score, the degrees of freedom, in this case it will be one less than your sample size, and the two-tailed p-value, which does not look like a significant value in this case. That's how you use the Vassar site for doing a one sample t-test.